Hello everyone. I want to welcome back again in my this video. Today here we are going to learn about uh, one simple experiment regarding thermistor in our physics lab. Okay. The name of our experiment is to study the resistance versus temperature of a given thermistor. Okay. Mm, we need to understand the relation between resistance and temperature of this thermistor. Before that, we need to understand what is a thermistor. Okay, what is a thermistor? It is a semiconductor. Okay, it is semiconducting device which whose resistance changing, okay, according with temperature, and sometimes it becomes conductor, and sometimes it becomes resistor with the variation of the temperature. Okay, sometimes it becomes insulator, that means high resistance. Okay, and sometimes it becomes a conductor with a low resistance. Okay, this is the interesting practical in physics. Okay, so I want to tell again, thermistor is such a device, a semiconducting device whose temperature and resistor keeps temperature and resistance are either directly proportional or inversely proportional. It means that there are two types of thermistor. One is positive temperature coefficient and another is negative temperature coefficient. What do you mean by positive temperature coefficient thermistor? It means that if temperature increase, then the resistance increase. That means from conductor to insulator, it is moving. Okay, high resistance means insulator have a high resistance. It do not allow any kind of current to flow through it. So that is called a positive temperature coefficient thermistor. Another is called a negative temperature coefficient thermistor, which if temperature increases, then the resistance decreases. Okay, so here we are going to deal about a thermistor in our lab, and we'll find out whether it is positive temperature coefficient and negative temperature coefficient. But our work is very simple. Our work is to study the resistance and temperature. If you give temperature, what will be the resistance? We'll draw one graph and we'll finish our practical. If there is some error, we'll calculate that, but that is another part. But we'll see how to do this practical. See here, mm, it is a practical arrangement in our lab. Okay, here is a water. Okay, in a beaker, down there is a burner, gas supply. Okay, and water is there, and there is one small test tube. Okay, inside that thermistor is there. Some oil is kept. Okay, and which is dipped into the water. That means when the burner gives heat to water, okay, then water supplies heat to oil, and oil supply heat to thermistor, and thermistor is connected to this device. I'll talk about this later. And by this way, the temperature of thermistor gets increased, and along with thermistor, we have placed one thermometer. Okay, with the help of that, we'll find out the temperature of this thing, and temperature of thermistor, and at that temperature what is the resistance, we'll see about with this device. Okay, as I want to talk about this device is a PO box. Okay, we call it as a PO box. Let us see about the arrangement of this PO box. It is same. Okay, down also there is same. Okay, it is in S shape. Okay, it is in S shape. You can see here. Okay, it is in the shape of S. To change this color to red, I'm going to increase a little bit my thickness. Okay, it is in S shape. You can see here. Okay, it is in S shape. Okay, it is the thing to be known. Okay, it is in S shape. So now I want to drop this, and I want to go for the detailed view of this PO box. Okay, it is divided into several terminal. Okay, this PO box is divided into several terminal. You can see that this point is A, this point is B, and this point is C. You can see here, where is ABC? A means this point here, it is written A. This point is B, it is written over here. This point is C, it is written over here. Okay, ABC. And here A and this point is connected. Okay, A and this point is connected. Okay, between between the A and B, there are three resistor. One is removed over here. Okay, this point is called P. Okay, this point is called P, and this one is called Q. I repeat again, between A and B, there is P, and between B and C, there is Q. Okay, A, B, C, we know. P, Q. Okay, it is P, it is Q. Now, what we'll do is from A to this point, okay, from A to this point is D. Okay, this point is D. From A to D, okay, here it is only this much, but here from A to D means this one line, okay, all here to here. We have a several resistance, okay. So with the help of this resistance, we'll find the resistance of those thermistor which is placed over there. Okay, here is D. And there are two key, okay. One key is here, one key is another. This key is connected with A. Okay, this key is connected to A from internal. A is here, okay. This key is connected from here to A. If you press this key, then whatever it is given input over here, that will be connected to A. It means that, okay. Another, this is connected to B. So whatever you have connected on this terminal, it will be connected with B. Okay, whenever you press the key, otherwise it will be disconnected. Okay, it is very simple. Okay, A and B, bit A, B, C, and this one D. Okay, A and this key is connected, B and this one is connected. So we'll make the experimental setup of this. Okay, between A and B there is P, and between B and C there is Q. Okay, this one is the thing. So we'll talk about this later. What is connected? Battery and one galvanometer is connected. So now, what is the use of this PO box? Okay, this PO box was used in the ancient age, okay, ancient time, to transfer the information from one place to another. Okay, at that time, the information was transmitted from one post office to another post office with the help of wire. Okay, and sometimes the wire may break due to some storm and all. So to detect that breaking, when the wire breaks, okay, when the wire breaks, then what happen? If the wire breaks, then what happen? There is a more resistance. Okay, that means insulating. Okay, if the wire breaks, then there is no connection. No connection means no current flow. No current flow means high resistance. So to detect that, this PO box is used to detect where there is a mistake. Okay, so that is the thing to be known. It's very interesting. Okay, so this PO box, okay, we are using it under the principle of Wheatstone bridge. Okay, as I told you, between A and B there is P, and between B and C there is Q. Okay, there are three resistors, 10 ohm, 100 and 1000. Okay, 10, 100 and 1000. Here I have removed 100 and 100 to make P and Q equal. P and Q are equal resistance now, 100, 100. Okay, so that's why I've removed this middle one, this 100, and this 100 from P and Q. Okay, so from here to here, there is the total resistance. So now you can see here, this P and Q is already kept how much? 100 and 100. Okay, this one is also same. So now this R and X, what do you mean by R, what do you mean by X? Okay, R is the known resistor from A to D. We know from A to D, this point is A. Okay, this point and this point are connected, and from A to D, there are several resistance that is called R. Okay, there are several resistance that is called R, and from C and D, we are using the unknown resistance of thermistor. That is, the two wire is coming from thermistor. You can see here that is connected one to A. One wire is connected to A. Here wire is not connected, but it should be connected. One wire to A, another wire to let us see. One wire to C, one wire to D. Okay, A, B, C. It is connected to C here. Okay, and another is connected to D. Now, what we'll do is, now we'll connect one battery. Okay, this one is negative, small one, and greater one is positive. Now we'll connect the positive terminal to C, negative terminal to A. Okay, in your battery there is written positive, negative. You can see there. Otherwise, in our battery, okay, there is one small coming out. Okay, from a battery. Okay, there is battery. this pointed one which comes out, that is positive, another one is negative. Okay, don't forget to connect positive to C and negative to D, and resistance we have connected this one already in PO box. Now with the help of this, we are going to find the resistance of thermistor with the help of PO box. Now how, that is the thing. Okay, this is the experimental circuit of thermometer, and whatever the wire is coming here, that is called X. It will be connected one to C, one to D. Okay, A, B, C, D. This point is D. Now I want to move little bit further. What we have done till now, we have just connected all this experiment, all the wire has been connected. I want to erase this drawing. Okay, now what we will do is we'll give heat to thermometer, okay, this thermistor, and whatever the resistance is here, we'll find out with the help of PO box. But before that, we should know the principle of this Wheatstone bridge. At the balanced condition, okay, this Wheatstone bridge now have a formula P by Q is equal to X by R. Okay, P by Q is equal to R by X. Okay, P by Q is equal to R by X. It is the formula of Wheatstone bridge. So what we'll do, if P and Q are equal, it cancel each other, it will be equal to 1. Okay, then is equal to R by X. Now what we'll do, R will be equal to X. That means whatever the resistance is there in the PO box, okay, that resistance will be equal to the resistance of thermistor. Okay, resistance of thermistor and the resistance of PO box will be equal under the balance condition. So that's why we have removed 100 and 100 from P and Q. Okay, we can remove 1000 also, but let us remove the midterm. So that's why we have removed 100, 100. So there is a logic behind that. So after this, okay, after this, what we will do is there are two different keys over here. Okay, so there are two different keys. Now what we'll do, without connecting whatever the terminal we are going to connect to A, we'll give the connection to here. Okay, we'll give connection here. That means the battery terminal, the negative of battery is supplied to A. So negative of battery will supply here and we'll press the key. Whenever we press key, this will be connected with A. Okay, until and unless you don't press key, then what even? The battery will not be connected to A and the whole experiment will not work. So whatever you are going to connect to B, so you will connect to this terminal, and whenever you press the key, okay, then this B will get data. Okay, so sometime here this experiment cannot be performed easily with the one person, so that's why we have connected A directly over here so that this key is always on. Okay, and what we'll do, we'll connect the galvanometer. Okay, you can see here the galvanometer is connected to B directly, but here the galvanometer will not be connected to B, it will be connected to here. Okay, this point is B, and we'll only use this one key to detect the resistance, because if you have a more person in your lab, then you can connect A here, you can connect to B here, and you can press both the key. Okay, I hope I have made you clear. Otherwise, you can see this video again by doing little bit reward. Okay, we call it forward reward. So okay, this thing. So now what we'll do is you will see the deflection in galvanometer. Okay, deflection should be little bit minimum. Here is 0 and here is higher, here is more. Okay, so deflection should be minimum. At the minimum deflection, what will be the resistance? That resistance will be equal to the resistance of thermistor. So slowly will provide heat. Okay, slowly will provide heat. I think the temperature will be equal to room temperature before 27 degrees Celsius. Okay, whatever be the temperature. Okay, at that time you supply heat slowly. At that time you set up this PO box from A to D, never remove from P and Q. Okay, from A to D you remove certain resistance so that the value of galvanometer will be slightly little deflection from 0, little bit minimum. Okay, negligible deflection from 0. Then at that time you can notice the temperature of this the temperature of this thermistor with the help of thermometer, and at that time what resistance is there, you make a note of that. Okay, and each and every 2 degree temperature increases, at that time one person will see this, another will press the key and will see the deflection. Okay, while pressing the key, this galvanometer deflections will be little bit minimum. So at that time, what we will do, you will remove the resistance, okay, this key from this, and whatever the resistance is removed, you will note down that. Okay, so you will continue from the temperature of 27, 26, 25, whatever be the room temperature, from that to little bit increment, that is within the 2 degrees Celsius increment, up to about 85 to 90 degrees Celsius. That means some reading will be there. So you will note down that reading. Okay, you will note down that reading, but don't forget to press the key. Without pressing key, the galvanometer will not be connected with B. Okay, so at that time, what happens, whenever you press the key, and then you can see the negligible deflection. If the more deflection, don't note down. If the negligible deflection, then only you note down. Negligible means slightly unnoticeable deflection, little bit. Okay, so that deflection will be noted, and the resistance in PO box will be equal to the resistance of that thermistor. Okay, now what we'll do, we'll measure the data. You can see from 32 it is taken 32, 34, 36. Okay, increasing temperature and decreasing temperature. Whenever you increase the temperature, after that you remove the heat and you take the temperature of decreasing also. At that time, again the resistance you can notice. Okay, from up to down and down to up. Okay, it will be easy. It is the trick to know. Okay, now at 32 degree, okay, what will be the reading of the resistance? You can see here 6370 ohm. Whenever the temperature increases, you can see at 50. At 50, what will be the temperature? You notice this one for that. Okay, 3000. See, at 32 degree, the value of resistance is, for I means increasing. Okay, whenever you increase the temperature, at that time we're at 32 degree, that means at low temperature resistance is high. At the higher temperature, resistance is becoming low. That means it is inversely proportional. So this type of thermistor is known as a negative temperature thermistor. You will note down this reading. Okay, you will note down this reading. This temperature you can note down from the thermometer. Okay, this one resistance you can note down from the PO box, and that resistance will be equal to the resistance of that thermistor. So with the help of this, you will get this data, and after that, whenever you analyze the data for the increasing temperature and decreasing temperature, you will get the two graph. Okay, two different graph like this. This one is for the increasing temperature. For increasing temperature, there is the resistance. Okay, there is the temperature. Okay, at what temperature what resistance is there? See here at 32 degree the resistance is high, and at 50 degree or some more degree, okay, 80 degree, the resistance is becoming low. So this is the property of thermistor. So today in our class we know about what is thermistor, what is PO box, why was it used before, okay, and what do you mean by Wheatstone bridge. Okay, it is the experiment diagram of Wheatstone bridge and the balance condition of Wheatstone bridge, and after that how to measure the resistance of a thermistor, how to connect this in a circuit, how to use this key, and whenever you supply directly to A, these keys will not be in use. Okay, don't press the key because it is already connected here. It means it is already always placed. So whenever you connect this to B, that means this is always placed. So it depends upon you, okay, which one you want to press. Okay, so you make your experiment simple. Okay, it is a very simple experiment and very important experiment. Okay, it is very interesting experiment too. So I hope you are clear in this video. So I am very much thankful to you all for giving time to listen this video. Maybe you have got some knowledge which you didn't acquire before. So if you have got some knowledge, please comment in this video. Okay, and I want to sign off from today's class. Okay, thank you very much and bye-bye.